Hello guys, welcome you all to part 1 of my tutorial series on C programming. In this video we'll see what exactly is the concept of programming and how a computer works, so we know exactly what we are doing in the rest of the course. So before programming, we need to understand how exactly a computer works. Computers are becoming an essential part of our life. They do a lot of tasks. The most important component of the computer which does this task is the CPU, which is also called the brain of the computer. Everything the computer does is because of this CPU. But this CPU, although it's called the brain of the computer, doesn't have any intelligence. Or you can say this CPU is a dumb machine. It can't do anything on its own. For instance, we say, hey CPU, what is 1 plus 1? It's not going to understand that. A CPU is designed to do only one task, just one. That is, to do whatever it is asked to do. Or in other words, we need to give it instructions. And only it can understand only that instruction, and it will blindly follow the instruction. You give it instruction how to add two numbers, it's going to perform and tell you the result. That's all it can do. You can think of it like a pocket calculator. A simple pocket calculator, the most basic ones, can only do addition, subtraction, multiplication and division. It cannot do, for instance, average. But by giving it right instruction, we can do average in a pocket calculator. We have to add the numbers first and then divide by the total number of values. So addition can be done by the calculator and division also can be done by the calculator. But the order and the proper structure has to be given so that we can find the average. The CPU works exactly the same way. A CPU can do only certain basic operations like moving data, performing arithmetics or outputting data. But to do complex tasks, we have to give it instruction in terms of these basic instructions so that the CPU can perform the task which we want. And by the way, this is not even the instruction that we give to the CPU. The actual instruction that we give is in binary form, which looks something like this, only ones and zeros. Now let's get to the point of what is programming. Now that we know that we should give instructions to the computer to make it work, the process of giving this instruction is called programming. The instructions themselves are called programs. Or in other words, we can say programming is like talking to the CPU or communicating to the CPU. When we communicate to the CPU, we need a language for communication, and that language is called programming language. So in simple words, we give instructions, or we talk to the CPU by giving it instruction in a language which is called programming language. So there are three types of programming languages here. There is machine language, there is assembly language and high level language. The machine language is what the CPU actually understands. As I showed you in the previous slide, it consists of just zeros and ones. The assembly language is a language that is a little bit understandable. It uses mnemonics or codes of instruction that the CPU can run. Instead of representing the instruction as mere numbers, we use mnemonic codes that we can easily read compared to binary. That is assembly language. A high level language is what we all know of: C, C++, Python, Java, and the list goes endless. So all these are high level languages. Now we know CPU understand only machine language or binary language. Now why is that? Basically, CPU is just an electronic circuit. What's inside a CPU is just transistors and electrical connections. CPU works fully on electricity. So in electricity, 1 is a higher voltage and 0 is a lower voltage. Everything is in terms of voltage there. So it can only understand higher voltage and lower voltage, which is what we call ones and zeros. Okay, now the CPU can only understand binary language. So if programming is communicating to the CPU, how do we communicate to it? Like if you say, hey there, it's not going to understand English, or it's not going to understand C programming either. We have to talk to the CPU in terms of a binary for it to understand. Well, to give instruction to the CPU in binary is actually possible, but it's not practical. Even the very simplest task would require thousands of instructions, and writing thousands of instructions in binary just to do a simple task is not quite practical. So what we do is we introduce a new component here called a translator. Let's consider this scenario. Your friend can understand only French, but you want to tell him some instructions, but you can talk only in English. How will you convey some instructions to him? Well, you can have another person who can understand both the language and translate between them. So you can tell the translator your instruction in English, and he can in turn translate it and convey the instructions to your friend in French. That's what is happening here. We use our high level language like C++. We talk to the translator, and the translator talks to the CPU in its language, and the CPU accepts the instruction and performs the task. Now this translator is what we call as compilers and interpreters. Well, translator is just a abstract term. The actual program that we use for translating is called a compiler and interpreter. The only difference between a compiler and interpreter is the way it works. Compiler translates all the entire message at one go, whereas an interpreter translates and speaks to the CPU line by line. So there's an interesting fact to be noted here. Compilers and interpreters are themselves programs. So we'll see more about compiler and interpreter in the coming videos. Now let's summarize what we saw in this video. Computers are dumb machines that can't do anything on their own. To make it do task, we need to give computer instructions, which we call programs. CPU understands only binary language. To translate our high level programs to binary language, we use translating programs called compilers and interpreters. The programs we write are translated or compiled and executed by the CPU to produce our desired output. Now that's how a computer works. I hope you have an idea of the concept of programming and what exactly we are doing by programming a computer. From the next video onwards, we'll dive into C programming language. Thanks for watching my video, and I'll see you all in my next video. If you have any questions or comments, you can leave them in the comment section below. I'll be glad to help you. See you in the next video. Bye.